In this lecture, we're going to implement infinite scrolling. Now that we can detect that a user has scrolled to the bottom of the page, we can initiate a request. We'll be working in the handle scroll function we defined in the home component file. We'll update the conditional block to call the getSongs function if the condition is true. We can move on to updating the request in the getSongs function. Currently, we're requesting the entire dataset from Firebase. The problem with this function is that we're not limiting how much data we're requesting. We don't need to request the entire dataset since we're going to add infinite scrolling. We'll modify the query we're performing in this function. Before we call the get function, we're going to chain a function called limit. The limit function will limit how many results are returned by the API. It has one argument for how many results should be returned. We're going to be using the limit function a few times in our component. It would be a good idea to store how many results per page we want in the data function. We'll add a property called max per page. We'll set it to 3. We're using a low number because we want to be able to test infinite scrolling. We don't have a lot of songs uploaded at the moment. After we're finished with this lecture, we'll bump the number to a more reasonable value. Back in the getSongs function, we'll pass the max per page data property to the limit function. This query will tell Firebase to retrieve the first 3 results from the database. There are additional adjustments we'll need to make. The goal is to grab the next batch of results. We can get the next batch by telling Firebase about the last document we requested. By telling it about the last document, it'll start searching for more documents starting from the last document. Let's write the code to understand better how this works. We'll chain the startAfter function before the limit function. We're telling Firebase to start looking for documents after a specific document. You can imagine it like telling JavaScript to return items in an array after a specific index. The startAfter function has one argument. It's the document it should start at. At the moment, we don't have the last document. We'll make a query for it. Above the query, we'll declare a variable called lastDocument. Its value will be the songsCollection.document function with the await keyword. Next, we'll pass in the following value. This.songs, this.songs.length minus 1.document ID. Lastly, we'll chain the get function. Let me break down what's happening. The startAfter function requires we pass in a snapshot of the document it should start from. We don't have the snapshot, so we're performing a query for it by calling the document function. We're passing in the ID of the last object in the songs array. The query we've written should return a snapshot of the last document in the array. We're initiating the query with the get function. We'll pass in the last document variable into the startAfter function. There is one caveat with using this function. We are required to set the order. Firebase will automatically sort the documents in random order. The startAfter function doesn't like that. It wants us to order the documents before retrieving the results. We can order the results by chaining a function called orderBy at the beginning of the chain. We can use this function to order the results by a specific property in the document. We'll use the modified name property to sort the results. This query will return the next 3 songs in the database. It'll always start the search after the last set of documents. However, that's a problem. In the query, we're using the startAfter function to instruct Firestore where to begin the search. It'll use the document object we passed into it. If the user is visiting the page for the first time, the object we're passing in will be an empty object. This will break the query. We can't grab the last document until we make a query, and we can't make a query until we have a document to provide it with. We can resolve this issue by creating 2 queries. We'll wrap this query with a conditional statement. The condition we'll use will check the length property on the song's data property. The song's data property will initially be an array. If there are items in the array, it's safe to assume we have a document object we can use in the query. If this ends up not being the case, we'll create an else block with the same query. We'll remove the startAfter function from the query. This query will get the first 3 songs it finds. It'll always be used for the initial request. If the user scrolls down, the query in the first conditional block will be used because the songs array will have been populated with some songs. We'll need to move the snapshots variable declaration above the chain of conditional statements. We won't be able to use the variable if it's declared in a conditional block. We're almost finished. There's one last thing we need to consider. It's possible the user may trigger the request multiple times while a previous request is still pending. If we don't account for this scenario, it could lead to inconsistent results. We can fix this problem by keeping track of requests. In the data function, we'll create a property called pending request. Its initial value will be false. Let's go back to the getSongs function. At the top of the function, we'll create a conditional statement that'll check if this property is set to true. If it is, we'll return the function. If this property is set to true, we'll stop further requests from running. It'll tell our component we already have a request for songs being made. We'll need to toggle this property in our function. After the conditional statement, we'll set this property to true. Then, at the end of the function, we'll set it to false. We're finished. Let's try testing the application. In the browser, try refreshing the page. The page should be able to display a set of results without us doing anything. I recommend opening the console to check if there are errors. We won't see errors in the console. So far, so good. Let's scroll to the bottom of the page. After doing so, we'll be presented with more songs. We've successfully created an infinite scrolling page. We'll update the max per page property. We already know that infinite scrolling works. We can bump this number to a more reasonable number. We'll set this property to 25. Let's switch back to the browser. If I were to attempt to force the query after we've gotten the full list of songs, I'd be blocked from doing so. We've successfully created an infinite scrolling feature on the home page.